All right, hello guys. My name is Lazaro, and today we're going to be doing a Git workshop. Now, this is part of the Solutions Challenge series, which is basically every single Thursday we host a workshop just to help our members complete an amazing project for the Solutions Challenge. So yeah, let's get into Git, which is an intro to version control. That's what this is all about. Okay, so my name is Lazaro Hurtado. I'm going to be graduating in 2023. I'm the DSC FIU Vice President, currently a sophomore studying computer science, and I do majority of backend engineering, uh, Python, JavaScript, Node.js. Yeah, so that's that. Awesome, cool. So now let's get into the actual workshop. So what is Git? Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. So as you're working on your project, it's very important to keep track of your changes and what you're doing or what other developers on your team are doing. And that's exactly what Git can do. Let me actually escape out of this. Let me go to this slide. And just in case you guys don't have it already installed, I put the link in chat. Make sure to download it, Windows, Mac, Linux, whichever, because we are going to be using it for most of this workshop. Now, the long-awaited question is, what is GitHub? We just talked about Git, but if Git is that, then what is GitHub? Because there are two different things. Well, here I'm. You guys can read it, but I'm not gonna read it. Uh, Short story is that GitHub is basically the user interface of Git. It's just the UI. It's just a website for Git. But GitHub does a little bit more than that. Not only does it supply the information and the same things as Git, but it also supplies other things. You can create projects, not projects. You can create organizations. They also have basic task management tools, and you can create wikis for your actual project. So this is something that Git doesn't offer. If you don't have an account with GitHub, let me also send this in the chat, and it's right there. Cool. So now that, does everyone understand what Git and GitHub is? Yes, show of hands or in chat, whichever.
So GitHub it basically just stores all of the Git stuff, like just separate Git repos and whatnot.
Exactly.
Okay.
Yeah, exactly. Get repositories or commits, all of that. Cool. So a lot of people put the thumbs up and stuff. So this is great. So now let's carry on. Now I'm going to be going over today's agenda. We have some, we're obviously not going to be covering everything. There are some things that are left out because you will most likely never use it and while you're working with Git. But we do have the basics. Here we know how to configure Git. We're gonna learn how to create repositories. Then we're gonna learn how to make and review changes. We're gonna learn about branches and merging. We're gonna talk a little bit about storing changes. And then finally, I'm gonna throw in some extra stuff that could be useful and that you guys could use. So let's get right into the first one. The first one is configuring changes. All right, cool. So to configure your Git is right after installing it, you want to set your username or just your name and your email. Uh, the reason why you want to do this is because for every single commit you make to a repository, it uses this information to add it so people know who made the commit. Here, right here in the bottom, I have an example code of how that could be done. If you pass it this option right here, so that's minus global, it stores your name and email for the whole system. If you just want to do it specifically for one system, or let's say you have multiple users on your computer, just exclude that part and it will save it only on that user. So this is the first thing you guys want to do once you have Git installed. After that, there's pretty much nothing else. You could do a little bit more things like this. You can change a couple of colors for your branches or for your committing, but that's just extra. If you want to get into that, then I suggest you search it up because it won't be covered here. So now let's get into the next thing. One of the biggest things is creating repositories, which is basically like creating a project and where you're going to hold all of your information, all your files. So you can create a repository using git init. As I can say right there, but this repository is to be local. So by local, it means that it's only going to be held on your computer. Now, like I'm also saying here, is this command is usually called without any options. Most of the times, 90% of the times, you just do git init and that's it. But there is a pretty nice feature that I learned while researching to make these slides is that you can pass this option, this dash dash or minus minus branch. Might as well do this. Okay, should be a little bit better. So what this does is when you do git init, the default branch is called master. They're trying to change it to main, but currently it's called master. But if you pass this option, this dash dash initial dash branch, whatever word you put after that, that'll be the default name of the branch. So here in the second code right here, the default branch, instead of being called master, it will be called DSC FIU. Cool. Can you guys, just out of curiosity, see the pointer on my screen? Yes, cool, thank you. All right, now let's talk about creating a repository on GitHub. I actually do have to exit out here. So I'm gonna go over to my GitHub. This is the DSC FIU GitHub. To create a repository is extremely simple. Once you have created an account, you see this plus sign in the top right. Click on it and then click on new repository. From there, you're gonna see a couple of options, and the first one being repository name. So we can name this GitHub workshop. I know how to type. Okay, sorry, there we go. And then optional, you can just add a description to see, so you can write what the repository is about. And then of course you have the option of making this public or private. And then you have some extra little options on here where you can add a README, and a README file is basically some basic information about your project. You can also add a .gitignore, and a .gitignore is basically telling GitHub or Git which files to ignore. If you add a file to .gitignore, when you push to GitHub, here in your repository, that file would not be shown because it got ignored. And then you can choose a license, which is just some extra stuff for your project. I don't know, intellectual property. I'm not sure, but it's just licensing. But of course, all this is optional. So I'm just going to straight up create it right now. And bam, I created it. Now, some pretty useful things about GitHub is as soon as you create it, and since it's empty, you name it the same as you init. So, okay, let me go back. Here, you're init, your dash dash initial branch, and that's not the project name. That's not the repository name. That's just the default branch. But I am going to get to what you're talking about in one quick second. So for example, right here, once you create it, and since there's no files, it gives you some information. Here, of course, it tells you to initialize a repo or a Git in the folder. And then you can also add a README, but that's optional. But the most important thing, the thing I really want to emphasize is git remote add origin. The reason why I would talk about that is because right now on GitHub, this repository is remote. And on your computer, when you did git init, it was local. So to connect those two, you want to do git remote add origin. And then you get this link from the repository you created. It's this one right here. You can either use the HTTPS or the SSH, whichever works for you. Okay, so that's how you connect your local to your remote repository. But of course, you do want to follow these steps before, because if you want to push your code, which we'll talk about later in the workshop. Cool, so now you have it connected, beautiful. I should actually, I'll download the repo later. I'll download it here. So now another option of creating a repository alongside init and alongside creating it using GitHub is you can clone the repo. So as this said, if you like to access a repo that already has some code on it, then you would need to clone it. It doesn't need to already have code on it. For example, right here, I can clone this one and it has nothing. Cloning a repo takes the HTTP, and they should include an S, or an SSH, which as I showed you, is these two right here, these two links. And then after cloning, you will have the repository downloaded in the directory you cloned it in. So let's go over that. So I'm going to be getting this link. I'm gonna use the HTTPS. And then I'm in my projects. So here I'm gonna do git clone. And then I'm gonna click enter. And then it says you appear to have cloned and enter repository. Let me actually see GitHub. There we go. Cool. So even though it's empty, it still allowed you to clone it, and it's now in your file. So for example, if I were to go back and I list everything, all my folders, you will see that the GitHub workshop is right here. And that's the folder. Sweet. So now let's carry on. Now, another way of creating a repository or creating is by forking a repo on GitHub. So forking is commonly used when you want to propose changes to someone else's project, or you want to use their project as a starting point, as a boilerplate. And forking can only be done on GitHub, but after forking a repository, it'll be saved on your account, and then you can clone from that. So an example of this is if I were to go to my account, right here, this repository is forked, as you can see right here. But since I forked it, it's saved in my account, and it has all the code from where I forked it from. Now, since it's saved on my account, I can just take this link, the HTTPS, and then go back to my terminal and clone it. And I can do whatever I want with it. Obviously, you could also go to where it's mainly from, which is from this user right here. And then you could also clone it from here. But now let me show you how to fork. So let's say I was on someone's account I don't know. I really don't know this person, so this is a perfect example. If I want to fork this project, I will go up here where it says fork, and then we'll click on it. Oh, whoa. Okay, so now it's going to automatically do it. And it's gonna be forked to DSC FIU. I thought it was gonna ask for confirmation, but it doesn't ask for confirmation. It automatically does it. I'll delete this later. All right, so that's that. So now you guys learn how to use Git init to initialize a local repository. You guys also learn how to create a repository by going straight to GitHub. You learn how to clone an already existing repository and get it on your computer. And you guys learn about forking. So those are a couple of ways of creating or really copying repositories. Now let's get into making and reviewing changes. Yeah, so forking here, so like I said in this slide, the main reason why people use forking is when you want to propose changes. And the reason I had that forked on my account is because I was making some changes to it, which you can see. Once I made changes to it, I created a pull request, which I'll talk about later. And then now I'm proposing these changes to the owner's repository. So I copy the repo, I make some changes, and then I'm asking for him to accept it. So, and then this is just the changes right here. Okay, cool. And will the person be notified you forked it? I believe not. I don't think you get a notification every time someone forks it. But I could be wrong about that. In fact, if someone forked. Let's search it up real quick. Okay, so no, it doesn't tell you. But it does give you the option, like right here, and it tells you how many times it's been forked. Yes, exactly, Miguel. If he accepts this pull request that I made, then I'll be listed right here under contributors of his project. And then if you click on the number and Nathalie, you can see everyone who has forked it. So it probably doesn't tell you, but you could see the list. Cool. All right. All right, nice. So now let's get into making and reviewing changes. Is everyone cool with the repositories? Yes, nice. All right, I'm gonna continue. If there's any questions, just put it in chat. So now let's talk about adding files. So if you want to make a change to a repository, you can add that file and stage it by using the add command. Staging a file basically means that it's ready to be committed, which we'll get on late, which we'll get to later on. You can also add all the change files by just using add period. So let's go over this. So this is a folder in the repository that we made, and remember it had no files, so which is why this is empty. So let me just create one. Example. Wow. Okay, .txt. I'm gonna put hello there, or just hello. Make it simple for myself. Then, and then if you're using as a text editor, not sorry, as a IDE VS Code, you see this U. This U means there's unstaged, I believe, files, or basically there's changes here, untracked files. But now we want to keep track of these changes and we want to stage it. So let's do that by using the git add. Once I do the git add with the period, so I'm basically be staging every single files that are untracked, and I click enter, you will see it moved from changes to stage changes. Very cool. So there, I basically just explained how to use git add, but there's also a couple other features you can use. It doesn't always have to be with the period. You can add a specific file by writing out the name of the file, or you can add every single file that's untracked by a specific extension by just using that asterisk dot whatever extension you want. For here, the example is .py. So every untracked Python file will get add and will be staged. All right. So now let's talk about file differences. To check the differences between the current file on the repository and the changes you made, you can use the diff by specifying the file, or if you don't specify anything, it just shows you all the differences. So as you see, if I were to do git diff, it would show me nothing because before we didn't have any files. But yeah, not even if I do example. Yeah, there was nothing. So there is nothing to really compare to because before you had nothing. I should probably close this. Cool. Now, if you want to remove a file in the staging area, then it can be removed using the command right here, the git rm, and then whatever file you want to remove. Now, this command must take a file, so it knows which file you want to remove from the staging area. So let's go here. I need to use cache. Okay, there we go. And now it removed it and it went back to you. So the RM would have permanently removed it, but since I passed that cached option, it still has it. It's just in cached memory. And then I could have like 100% removed it using the -f by forcefully removing it. Right? And then finally we can commit our changes. So once you made all the changes you need and you have all your files staged, you can commit. A commit saves all the changes you have made to the repository and would never change unless you ask it to. And then all commits take a message to, and then this message, it's typically used for to describe what changes you made to the project. So if I were to go back here and I were to add that file back, okay, cool. And now let's commit. So as a message, I want to be as descriptive as possible because it might help other developers understand what your commit is about. All right. And then right there, I just committed. So committing is pretty simple. You could also use the AM, which if you already had files in your repository, but this is a couple of changes, you can just do it all in one run with this option. Cool. So everyone's cool with that. Yeah. No. So when you come, yeah. Yes. The U. So when you make a new change, for example, when you make a change, this U, it's untracked. So if you were to commit right now, it would give you new txt. It would say that there's untracked files because you need to make sure that you stage all your files in your project before you can commit. And you can work around this using stash, but we'll talk about that later on. So yeah, so you do want to do git add, and then you can commit. Bam, there we go. Okay. So now let's talk about branches and merging. Okay. So when you're creating a branch is basically like a split in the main branch of the repository. So that main branch you can split off, and these split are called branches, of course. But they're usually used for features, and then later on, once you build out the logic for that feature, they're merged back to the main branch. All the branches can be viewed using git branch, and a branch can be created using git branch and then the branch name. So let's actually do that right now. So let's say I'm going to create a new feature for this project, and this feature is called add users. So there, I just created a new branch called add users. I don't know if I can, I know some people are leaning in to see it. Wow. Right, that works a little bit better? Okay, cool. All right, nice. All right, so there, that's how you created a branch. Now, if you want to view all the branches, just pass a regular git branch. And as you see, we have master, which is the main branch, and then add users, which is the branch we just created. Now, since we created a branch, and as you can see right here, since master is in green and there's an asterisk next to it, it means that's the current branch we're on right now. But we want to switch. We want to go to the other one, the one we just made. Cool. So to switch to a branch is after you create it, you need to use git checkout and then the name of that branch you made. And you can also do this all in one run using git branch and then passing it the -b option and then specifying the branch name. So now first let's move to that branch. And I used git checkout, and then I wrote down the name of the branch I created, which happened to be add users. And as you see right there, it confirmed for us that we did switch. And also on my terminal, it tells me what branch I'm currently on. So if we were to do git branch again and list all the branches we have, as you can see, add users is now in green and there's an asterisk next to it, which means we successfully switched from master to add users. And now let's talk about the second one, this git branch -b or -b add users. So this is a way of doing it all in one run. Let me first move back to master. And then let's use, let's do that command. So now I want to create a new feature. Instead of add users, I want it to be delete users or delete user. As you can see, it both created the branch and switched you to that branch. So it's pretty handy. So now if we were to do git branch again, you can see now we have three. Master, which master, which is the main one, add users, which is the second one we created, and then delete user. And since delete user is in green and has the asterisk, it means that's the one we're currently on. Now we can also edit a branch. So if you wish to change the name of a branch, you can use the command shown right here. If you're on the branch you want to edit, then you just need to provide the new name. Oh, I misspelled it. All right, so let's say I'm in delete user and I want to change this name to delete one user. And as you can see, now my branch updated from delete user to delete one user. So if I were to show the list of branches, it also changed here, and I'm still currently on it. So now let's say I want to change add users. And then let's name it add one user. It didn't switch me to that branch. I'm still in delete one user, but if I were to list all the branches, you can see that it did change the name. So that's how we do that. Comes pretty in handy. I personally used it before when I create a new branch for a certain feature, but then I noticed a bug for something else, and I start to dive deep into that, and I fix that bug. After fixing the bug, I tell myself, oh, all of this code is towards fixing this bug, so I should rename my branch to something more appropriate, and then try to do a pull request and try to merge that to the main branch. So that's when you guys can use that. Okay. So now you can also delete a branch. So deleting a branch is almost as easy as creating one. All you have to do is pass in the D option. Then state the branch you want to delete. But one thing to keep in mind is the branch that's locally on your local repository and on your remote repositories are sometimes different. So to delete on the remote repository, you need to push to origin. So for example, if I were to refresh this, you see there's still nothing here. That's because I've only committed my code. I have not pushed my code to this repository. So we can get to this later. But for now, let's just delete a branch locally. So which one do you guys want to delete? The add one user or delete one user? All in your hands.
Add one user.
Okay, add one user it is. So let's do get branch, and then let's pass it a D, and then add one user. And then as you can see, it was deleted. So if I were to show the list of branches, it's no longer there. It worked just how we expected it. It's not, yeah. So yeah, that's how you do it. And if you guys can remind me to do this part after I push my code to the repository, I'll go over it. But currently, since there's nothing here, really can't do that. All right, so now let's talk about pushing a branch. So after making all the changes you want to your local branch, you can push your changes to the branch on the remote repository. So all the developers can see the changes and they can pull from there. So the following command will push the current branch you're on to the remote repository. But if it's your first time pushing, it's going to tell you something else. So if I were to just do git push right now, no, it's denied from my account, really. All right, let's not worry about this. Did I do remote add origin? I think it is. I always forget this part. Yeah, remote add origin. Oh, whoa. Okay, wow, this really messes things up. Okay. No, that's gonna take too long. Okay, it's fine. No, it's not. I should really probably do this. No, okay, it's fine. I just log into my account. Okay. So let's not worry at all. This is totally part of the plan. Get cool. Let's recreate it. So let's just go over everything we just talked about. And then let's close this. So let's clone. I'm testing you guys to see if you remember what I went over. This was part of the workshop. So how do you guys clone? Does anyone remember?
Do you just put in? No, it wasn't in it. Never mind.
Close. But yeah, since I've already created here, I can just go ahead and just clone it and it would do that part for me. So there we go. I cloned it and now I can move on to Git WS. And now I can do the git remote add origin so I can actually set this up correctly and have access, hopefully. Okay. Now, okay, now let's open this. Let's actually add a file to it. Text.txt. There we go. And now, since it's on stage and on tracked, let's actually add it to the stage by using git add commit dot. Let's commit it. And then let's push. Oh, perfect. Nice. It worked. All right. Sometimes on the first try, when you try to push and oh, here, let me show you guys. So let's create a branch. Does anyone have any branch name?
Hello Kitty.
All right, Hello Kitty. There we go. And now we created the branch, and now let's change to it. Now on this branch, let's make some changes. Text one, sure. Cool. Perfect. Now we're on this branch, but there's some untracked changes. So we need to make sure that we're tracking those changes. So anyone want to tell me what command that is?
Git add.
Yeah. Perfect. And now let's commit new file. And now let's push. So this was the part I was talking about. For the first time when you're on a new branch, you need to set this option. And the reason why you're doing this is because the repository on GitHub isn't aware of this new branch you just created. So what you want to do is git push and then set upstream, just so that remote repository is aware of the branch. And then you pass it the beautiful name of Hello Kitty. And bam, you just pushed your code. So if I were to go to the file and reload, you can see that text.txt, this was the first commit. But here, this is how we switch branches on GitHub. Currently we're on master, but let's switch to Hello Kitty. Once we switch to Hello Kitty, you see two text files, text.txt and then text1.txt. So that's pretty much that. And we were on this one. Cool. So now you guys know how to push to your remote repository. And when you have a new branch, you know how to push that branch to the remote repository as well. And that's basically how, once you do a whole bunch of commits and you're ready to push your code, that's exactly how you do it. Cool. Now let's say you want to merge your branch to the master branch. Once your feature in the branch is finished, you can merge it to the main branch of the repo just using the merge command. But before merging, you want to make sure you're in the branch you want to merge the feature branch into. So if I were to do git merge here, I'll be taking master and putting it together with Hello Kitty. But you don't want to do that. You want to take master, you want to be on master and take any other branch and then push it into master. So first, let me check out. Cool. So now I'm currently on master. It tells me right here in my terminal. And if I were to do git branch, it will be in green, which it is. So now let's merge. So we want to do git merge and then the branch name that we want to merge into master. And of course, we had Hello Kitty. And bam. So we just merged it. And you can tell it merged it because in master, before we only used to have text.txt. But now we have text1.txt. We have both of those files. If I was smart, I would have named this something different so you could have really seen the change, but I really didn't think about that. Cool. So, and of course, let's check GitHub. Let's refresh. And you can tell this branch is still here. Do this, perfect, cool. So, but here on GitHub, the master branch, it doesn't have the second file because it's not updated with the local repository right here. So I believe you can, yeah, you can just do git push. And then that should be enough to update it, which it is. So now here on master, you have both text files. Okay, what if there were changes in master and I wanted to add them to the Hello Kitty branch as I'm developing in it? Okay, cool. So let's make a change to master. Let's actually go over that. I'm gonna be smart this time. Change. So right here, I have a change inside master. And let's actually push this code to the remote repository. So let's first add it. And then let's make a commit. And then finally, we want to push so it's updated in our remote. Right here, master changes. Now, we want to go to a different branch and try to get that changes in master to that separate branch. A new branch. So let's say you're working on a separate branch and you're making changes on it, but let's say you have a partner who has been working on his branch and his branch got merged into master. Now master is updated, but you want to get those changes. So to do that inside your new branch, oh, it is actually already up to date because there wasn't any changes. Let me add some changes. Hi. .txt. I'm still going to delete this repository after we're done. Okay, git add, and let's commit one more time. I should have created the branch before I actually committed. That was my my fault here. Okay, and now let's push. Now let's go to checkout to that new branch. So here it's missing that file we just created, but let's actually get that file, but by just merging master. So now we got all the info from master inside of Hello Kitty. Yeah, no problem. So you usually you don't really have to do this unless you're working on a big team and other branches are being merged into master. But most of the times, you just branch off and then you're just working on what master currently had. So yeah, there are some times you might need to use this. And if we were to refresh this, it has height.txt because of course we added and then we committed it and then we pushed. Exactly, yes, Miguel, am I getting close to that? Yeah, that's actually the next slide. It's this one right here. So creating a pull request. And this is very important because what I just did, merging to master, you never want to do. Unless you're working 100% by yourself, you don't want to do that. And you want your code to be reviewed by other developers to make sure that there's no bugs and what you're writing is actually correct. It's functional and it's useful. So let's talk about this. So we're working in teams. Pull requests are used rather than just merging directly to branches. Pull requests allows reviewers to look over your code, and if there are no errors, then they approve the merge. This is done through GitHub since there is no pull request command with Git. So let me first talk about this graphic that I think is extremely helpful down below. So as you can see right here, someone was on the main branch, and this main branch had all the code of the repository. Then they created their own branch, which is what this blue line is. This grayed out line is the main branch, but the blue one is another branch that the user created. As you see in this other branch, the user did some commits. They changed the code and they committed their changes. Then they created a pull request. This pull request is basically asking, can my branch merge to master? But an issue with this is that someone looked over his code, or this was a continuous integration software where it failed a couple of tests. Their code was not, it wasn't ready to be merged. So it failed a test, and then he made another commit. But with that other commit, it still wasn't enough. It still failed some tests. Then he made one final commit, which caused all the tests to be passed. Once all the tests were passed, his branch was able to be merged back with the main branch. And this is basically the workflow of a pull request. So I'm glad you asked that because I'm going back to this example right here. In this project that I forked, I also created a pull request. Here we go. So this is a pull request. In this pull request, you can add a title, and you can also add a description of what the pull request is, which is it's what you see right here. Remember, this is only done through GitHub, so I'm going to be going back to the repository and show you how to create a pull request. But right now, I'm just showing one that's already built. Right here in the pull request, you get the title of the pull request, the description, but you also get the commits. I only made one commit right here, so that's why it only shows one. If there were multiple, they will show more. Now, the person who can accept this are the collaborators of the project, the people who have access to this and could check it off. So if, I actually can't show you an example. I'll show you the example later. But this pull request page right here also shows you some more information. If you click on commits, it will show you in a better way all of the commits you've made. There's also some checks for continuous integration, but there wasn't any. And then it shows you all the changes to the files you made. So for example, here I made changes to .eslint.rc, to autocomplete textfield.js, and to a couple others. So this is what the pull request does. It shows you the changes and that you made on your branch, and it gives you some more useful information for the contributors or the maintainers of the project to determine whether or not your branch should be merged. So now let's actually create one. So as you see, this branch, the Hello Kitty, is 2 commits behind master. So let's create a pull request. Ah, damn it. Okay, let's first actually make some changes. Oh, I don't know what that is. So right now I'm in the new branch, and let's actually make changes here. Let's create a folder called source, and then inside that source folder, let's add another text file. And then here, let's add new changes. So inside of this branch, we want to git add to stage all the changes. And then let's make that commit. And let's do git push. But of course, since it's a new branch, we need to hook it up with the remote repository. Perfect. Nice. So now it says new branch had recent pushes less than a minute ago. Let's compare in pull request. So let's do it. Now I'm comparing the new branch. And this arrow says that I want to merge into master. So here I can put my title, and I can also put a description. And now I can create the actual pull request. I could do additional things like assign reviewers or add a label or put projects or milestones, but I'm not gonna do that right now. So once I create that pull request, it changes right there, and now you have successfully created a pull request. And then here over on file changes, it tells you the changes that were made. So since I'm a contributor and I can either merge or reject this, if I like this code and I think it's acceptable, I can click on merge pull request. There's also some more complicated things which I won't go over, but most of the times you're just gonna be straight up merging. So let's click merge and let's confirm the merge. And now it says pull request successfully merged and closed. So now if I were to go to code and I were to go to master, as you can see, the changes I made on the new branch is now in master. And that's because of that pull request. That pull request, it went through, got accepted, and then it got merged into master. So is everyone following with that? Everyone good with that? Or do you want me to go over it again? Okay, cool. Sweet. All right, only got a couple more things. Nice. Wait, yeah, Miguel, were you gonna say something?
No, I'm good. I don't know if you answered Matt's question.
Did I you feel good? You feel like I answered that for you? Or do you want to go over it? Yeah, okay. All right, sweet. So now let's talk about merge conflicts. So an example of a merge conflict is when 2 developers are working on the same file, and then when the developers try to merge, there'll be a merge conflict because Git doesn't know which file is correct. So merge conflicts can be fixed by having developers work on their own branch and then properly pulling or merging from one of the branches. So let's see if I can set this up. Okay. Let's see. Let's see. So I'm gonna make changes to hi.txt here in the new branch. But now let's go to, oh, this might be complicated actually. Okay, let's not try to make an example that might take up too much time. Instead, let's just look at this graphic. So here, okay. All right, Miguel, do you want me to answer it again?
Sure.
Okay, yeah, so only contributors and maintainers of the repository can accept or reject the pull request.
So if for example, your PR gets accepted for that project you're gonna be able to accept pull request from anyone after that?
If they give you, if they make you part of
The team.
the team, yeah, it's in securities
No, it makes sense. No, I get it.
or yeah, managed access. And then here, I can invite a collaborator.
All right. Thanks, man.
Yeah, no problem.
Just writing an essay at the same time. Sorry.
Sounds good, sounds good. Okay, so yeah, a merge conflict is basically there's a change in one branch, and then the other branch, there's also a change. And then when you try to push them together, Git wouldn't know which one to really handle, so it throws a merge conflict. Okay, and let's talk about pulling a branch. So once there's an update on branch you're working on, you can pull those changes to your local branch by using the following command, the git pull. And you have to do this while you're being inside of the branch you want to pull from. So I can't do this because I'm gonna need someone else. But let's say there's another developer working on the same branch as you, and then they push their changes to that branch. Now you on your computer, you don't have his changes. But a way of you to get his changes is by pulling. Did that make fine to everyone? Like, did that make sense to everyone? Yeah, okay, cool. Sweet. All right, now let's talk about storing changes. I definitely haven't taken a super long time for this workshop. So storing changes. If you want to switch branches without committing your changes, then Git will throw an error. And right here, as you can tell, I have created a change. So if I were to, wow, really? Okay, no, I need to, there we go. Okay. Oh, whoa, really? Wow, I'm definitely qualified to give this workshop. Okay, cool, or wool, nice. And now it should throw an error. Maybe not. Am I losing my mind? Okay. Okay, let's just, I swear it was like that before. All right, so okay, let's not worry about that. That's whatever commit. Okay, ignore that. Okay, yeah, let's just ignore that. Don't worry about that. So let's say you want to switch, but you without committing or deleting the changes you've made. Instead, what you can do is you can just stash them. So if I were to go back to, let's actually stay in this branch. So that changes I made to ince.txt, I can just do git stash, and now it saved those changes. So I could also do git stash push, so I can add a message to that stash. So later on, when I'm looking at the list, I know which stash is for what changes. So if I were to now do git stash list, as you can tell, those are the changes that I made, and it's stashed in Git. So let's say you make changes and you add it to your stash. If you want to get those changes back, all you really have to do is just git stash pop. But if you have multiple stashes, then you can also just pass it the index. and this index right here is 0. So let's say I want those changes back. You just do git stash pop, and then it got added back. Now I can just clear, and then git add. Cool. And then it went from blue to pink or yellow. So now you know that the change is actually updated. Nice. Now, so that's how you add to your stash, how you view your stash list, and how you pop from your stash. Let's say you want to add changes to your stash, but then you also want to drop it. If you want to drop a change, all you really have to do is just git stash drop, and it will drop the most recent one, or git stash drop and then pass the index number to specify which one specifically you want to drop. Cool. So now this is part of the extra, which is some just extra information or commands that you guys might be able to use. So the first one is we git log. So logging shows all information or all the information for the current branch you're on. And then this information includes commits, commit hash, commit author, and the commit date. So if I were to do git log, there you go. So it shows you the new branch, this commit, which it had a commit message of new changes, and then the second commit where I commit message of hello. It also tells you the author, which gets from your config file. If you guys remember the git config user.name, then user.email, and then the date. So that's just some useful information that you guys might want to use. And then the other one is resetting. So resetting does all the commits after the commit hash, you pass it. If using it regularly, like this first command here, the other commits that you removed, it's still going to be stored on your computer, and it's just going to be hanging there. But if you pass it the option of hard, then it permanently deletes all of those changes. So all of those commits, and after the commit hash you pass it, it'll be gone. Now, if you guys want to know how to get this commit hash, well, you go to git log, and it's this number right here. Cool. So other than that, that's pretty much it. Does anyone have any questions or want me to go over something?
Thanks, man. This has been the best GitHub workshop I've seen. So
It kind of fell off towards the end, but thank you, man.
no,
I'll take
no,
it.
because you went more in deep with
No, but honestly, I got it.
Thank you,
yeah,
guys.
like you showed how to actually like do PRs and stuff. Usually they never get that far, so
Yeah.
that's really good. Thanks, man.
Thank you. Thank you. No, thank you, bro. That means a lot. Thank you. My confidence was running pretty low there, but that helped.
Man, you're killing it. Don't worry.
Thank you. So, and now just a couple of resources that I use for these slides. I'm gonna paste it right here. Thank you, Kunza. And the first one being the documentation by Git themselves, which of course is one of the first things you go to. But sometimes documentation get pretty messy. So a website that was actually really, really nice was Atlassian, their guide for Git. They are amazing not only because they go about in-depth descriptions, but they also show pictures and diagrams and examples about how to do like pushes or merge conflicts, stuff like that. So I recommend this website more than the documentation of Git.
If you're confused about the branches and stuff, the one that I just sent is amazing. It's like visualize. how
Oh, it
happens.
visualizes it. Oh, whoa. Okay, yeah, this is pretty nice. Okay, I've actually never seen this before.
Yeah, the beginning is like tutorial, but then it like
Oh, okay, I see.
yeah, it's gonna be a little annoying in the beginning, but it's really helpful. At least for me, it was like because you see how like a bunch of different cases, which definitely for bigger projects you do see happen.
Yeah, being able to visualize these things, they can for sure help. So this is an awesome resource. Thank you, Miguel. So, and then after that, so those three, including the one Miguel just sent, really awesome. We put in the description. And also for GitHub, they also have documentation of their own, because there are some things that is exclusive to GitHub that Git just doesn't use. So that link was pretty helpful. So now, one of the final slides, it's what's next. We do have a trivia night with UPE on February the 26th at 8. That's pretty cool. Make sure you stop by. And then on March 1st at 7, we have a resume roast, which is extremely important, mostly since we're getting closer to that interview season. So having that nice resume is really nice to have. Make sure to follow us on Instagram at DSC FIU. Make sure to check out our website at dscfiu.io and to join our Discord server at go.fiu.edu/DSC Discord. And also, if you guys aren't already part of the Solutions Challenge, I highly recommend that you guys join. Pretty cool. It's also a really nice resume booster. You just create a project trying to solve a problem in your community and with a team of up to 4. So that's really nice. It's really, really cool. But yeah, finally, I do want to thank you guys for everything, for sticking through. Hopefully you guys enjoyed and learned something new. And yeah, hopefully it was useful.
Thank you for hosting it.
Thank you for watching me host it.
See you
All
guys.
right. Take care,
Bye.
Miguel.
Thank you everybody for coming. Ew, I can't believe my pillow was like this all the time. I'm sorry for those who had to see that.
All right, how was that? Dude, I feel like towards the end, it really fell off.
Yo, nah. Like to be honest, like I worked kind of with Git before. I had to for Spark Dev, and I was so lost. Like I had to ask my team lead for stuff all the time, and I think I actually got it. Like I couldn't answer your questions because I have a bad memory. Like I would have to look into the actual commands, but I did understand it completely.
Okay, that's good to hear. As long as it helped, that's nice.
Yeah.
Cool, cool, cool. All right, I think I'm going to end it. Oh, wait, let me pause the recording.
Oh no.